Today we're going to be graphing rational functions with slant asymptotes. Now you may recall a slant asymptote has no horizontal asymptote. And again, we want to get the asymptotes and the points. Just like yesterday, we want to sketch this function. Now we do want to see if anything will cancel, so we're still going to factor. X minus 3, x plus 2 over x minus 1. Get the domain. X can't equal 1. Ta-da! But we get that from the bottom. The bottom cannot be 0. Are there any holes? Nothing cancels. None, and that is because nothing canceled. To get the vertical asymptote, very easy. Our domain, because it's not a vertical asymptote, it's not a hole, it must be a vertical asymptote. So x equals 1, and this will be m1, because there's only one of those. To get the horizontal asymptote, just like yesterday, you compare the degree on top with the degree on bottom. So the degree on top is 2, and on bottom is 1. 2 is greater than 1. And from last year, you learned that the degree on top is bigger than the degree on bottom. There is none. Which means you cannot cross the horizontal asymptote if it doesn't exist. Don't have to worry about that part. Now, will there be a slant? Absolutely, there will be a slant. Because why? There is no horizontal. So, how do we get the slant? We divide. I'm going to take my polynomial, x squared minus x minus 6, and divide that by x minus 1. And I think, how many times does x need to go into x squared? X. I get x squared minus x. I'm subtracting, so I change it. My remainder is negative 6. So I get x minus 6 over x minus 1. Now, that's my answer. But to get my slant asymptote, all we care about is the whole part, the x. So we go y equals x. We don't really care about the remainder. To get the y-intercept, just like yesterday, let x equal 0. Look at the equation. X squared minus x minus 6 over x minus 1. Plug in the 0, and we get negative 6 over negative 1, so we get 6. So 0, 6. To get the x-intercepts, we let y equal 0. Same thing, 0 equals x squared minus x minus 6 over x minus 1. Because I'm cross-multiplying, the x minus 1 goes away. And the top I can factor as x minus 3, x plus 2. So my x-intercept, 3 and negative 2. So I can go 3, 0, negative 2, 0. And now that's going to allow me to graph it. So let's go take a look at a graph our function. List out your asymptotes. The asymptotes are easy. X equals 1. It was m1. And y equals x. That's our slant, right? There's our slant. There's our vertical. Get any points that we found along the way. We got the y-intercept, 0, 6. The x-intercept's at 3, 0, negative 2, 0. And now we're ready to graph it. X, y. Our first vertical asymptote at 1. And our slant, we know what the line y equals x looks like right here. There's my slant. There's my vertical. Now I graph any points. 0, 6, that's up here. 3, 0 is going to be over here. And negative 2, 0 is going to be right here. And now I can actually graph it. Remember, functions are attracted to asymptotes. So I'm going to go up through the asymptote here, and I'm going to go down towards the slant. Now the 3, where's it going to go? It has to go down the asymptote, and on the other side, it's going to go as quickly as it can toward this asymptote. And there's our graph. Please don't draw anything in here. Nothing goes there, because then it wouldn't even be a function. If I drew a line here, it wouldn't even be a function. Okay? All right. So, on your own paper, let's take a look at question number 2. Same idea. Same way. Now, we're going to be on our own paper now, so make sure you have your notes out. Number 2. Y equals 2x squared minus 1 over x plus 2. I can't factor the top, so I won't worry about that. So I look for any domain restrictions. What's the one thing x cannot be? Negative 2. Are there any holes? Well, since I couldn't factor anything, nothing cancels, so none. I can't factor, so nothing is going to cancel. Please don't say, hey, Mr. Wernow, those x's cancel. Don't do that. Every time you do that, a puppy died. And we like puppies. All right, now, So, since my domain restriction wasn't a hole, it has to be an asymptote. Vertical asymptotes and holes come from your domain restriction. And since my domain restriction is -2, it's either a hole or vertical asymptote. If it canceled, it's a hole. If it doesn't, it's a vertical asymptote. You can be one or you can be the other. You can't be both. That's M1, by the way. Looking at the horizontal asymptote, look at the degree on top, and look at the degree on bottom. On top it's a 2, on bottom it's a 1. It's greater, so there's none. Will it cross? You can't cross something that's not there, so it won't cross. Next, what do we look for? The slant asymptote. So we have to divide. X plus 2 divided into 2x squared, don't forget, plus 0x minus 1. Multiply, go x, this becomes x, whoops, sorry, 2x, sorry about that. That becomes 2x squared plus 4x. And let's see what happens here. Cancel, subtract. We get negative 4x minus 1 minus 4. And actually, to get as far as the slant asymptote goes, I'm done because we really don't care about the remainder. Anything left after that's just the remainder. So my slant asymptote becomes 2x minus 4. Next, we get the x-intercept. To get the x-intercept, let y, or the y-intercept, let's do the y-intercept first. Let x be 0 in our function. So there's my function, right? Let x be 0. I may write it down. Y equals 2x squared minus 1 over x plus 2. Let x equal 0, right? We get negative 1 over 2, so negative 1/2. So we get 0, negative 1/2. To get our x-intercept, let y equal 0. I go 0 equals 2x squared minus 1 over x plus 2. Cross multiply goes away. 2x squared minus 1. Be very careful. I get x equals plus or minus the square root of 1/2. And there we go. Now, that's 2 of them. So now I've got all this information. Let's graph this bad boy. Get our asymptotes. X equals -2, M1. Y equals 2x minus 4. Any points that we found along the way? 0, negative 1/2. Now be careful. Negative 1 over root 2, 0. And positive 1 over root 2, 0. That's our x-intercepts from down here. Graph it. Doesn't have to be perfect. -2, there it is. Negative 2 minus 4, so there's negative 4. Up 2 over 1. Up 2 over 1. Now, I may want to find out where this is located. Remember, that's going to meet at x equals 2. That becomes important, especially when you're looking at these points right here. My y-intercept, 0, negative 1/2. My x-intercept, negative 1 over root 2, so that's right over here. It's not less than negative 1, I know that. And it's positive 1 over root 2, so it's right over here. So if I graph it, it's going to look something like this. Not perfect. Now the question is, where is it going to be on the other side? That's where M1 comes into play. If it goes up on this side, on the other side it must go down. And I kind of ran out of room here, but hopefully you kind of see it's going to be right in here, in this little area. It's not going to be over here, it's not going to be over here. It can't be down here because then it wouldn't even be a function. So it's either one of these two. And I use multiplicity to tell me it goes down this way. And there's your graph. Alright, what I would like you guys to do for tomorrow is number 3 on your own. Okay? And then we'll take a look at it. So do number 3 and maybe number 4 on your own. So do number 3 and 4 on your own. Okay? And when you come back from the review, from the break, try those two, number 3 and 4, and then we'll do number 5 and number 6 together.